Up north from Canada, Vancouver. I'm not Canadian, so if my accent does bug you, it's not a Canadian accent, it's actually a South African accent. So I do apologize for some of the nuances I use. It is a little strange sometimes, and I get some people glazing over and some people chuckling because it means something else here. So I apologize for that. Come on in.
Thank you.
Sure. Did you have a lunch or?
I didn't order a lunch, Roland. I'm still hoping for just finished.
Okay.
Thank you for the offer.
Alright, so similar to Josh, I have an engineering background. Prior to coming to Canada, I was a consultant for 7 years in South Africa with a small consulting firm down there, and then later switched over to AECOM. AECOM a couple of years, worked on some nice big projects with them. And when I joined MCW Group up in Vancouver, a large mechanical firm up there, so I was there for about a year, and yeah, Lennox sort of poached me out of thin air from there because of my VRF background from a consulting standpoint. So my strengths are really design of VRF systems, the applications of it, and because I've got roughly 60 projects under my belt in South Africa that are up and running, some of them larger than others, obviously. And you know, I've been through the heap, if you can call it that. I've used the likes of our 2-pipe competitor. I've used the blue team. I've used the red team. I've used them all. I know everybody's issues. They all have issues. You know, it's just the way these products work. So to that end, you know, I try to apply our product as best I can, and I'm here to provide you and ACI with the engineering support that you need with an applied product like this. So without further ado, let's get going. So we're going to cover a couple of basic topics here. I'm not going to give you a what is VRF presentation, so if that's what you're after, please, it's not going to be what you're going to be getting today, so enjoy the lunch and then head on out. I'm going to be discussing some design considerations, items to look out for, items that we've picked up, and then really dig into our product line. Also not to a level that's really going to complicate things for you. It's really an overview to give you an idea of the products we have and how we're bringing it to the market and how we can best suit your needs. That's really the target that I want to reach today. So let's move on. So Lennox, you know, brand positioning, these are one of the slides that I like to keep in here purely because everyone knows Lennox. They may not have seen anyone from Lennox in 20 years. You may not have had day-to-day dealings with a Lennox rep or with a rep firm such as ACI, but everyone knows Lennox. Lennox has been around for 125 years actually. In the commercial realm, we've been around since 1964. So we have you know, paid our dues. We've been around a long time, and our products, you know, they sort of almost like tanks these days. They just, you know, when you get on that roof, the unit's 25, 30 years old, and that rooftop keeps on chugging. It doesn't stop. You know, it's easy to replace some parts, but that's the sort of Lennox legacy. It's equipment that lasts with a manufacturer that supports it well. And that's what we try and do with our VRF line. Now, again, here 1965 is what I mentioned. Now you need to ask yourselves, why would a reputable rooftop manufacturer and manufacturer furnaces come out with a VRF line? Why would we bring a VRF line like that to the market? Very simply, we needed to look at market trends, we need to look at where the markets are going, and we need to look at our product line in order to evolve. We have a responsibility to our investors, to our management teams, to move this company forward. And we're already, you know, a fairly big company with well over 5,000 employees, and we move a lot of product. We have our own distribution networks, we're big. So again, why VRF? Very simply, we've always done splits. To a certain extent, whether it's a furnace with a split, whether it's a standalone mini split or our commercial splits, rooftop package units with, again, refrigerant-based split systems, we've always done splits. We actually produced our first VRF split 30 years ago, which was our multi-zone split system at the time. It wasn't called VRF, but essentially it's exactly the same thing, all right? We took that off the market when there wasn't really too much of a tendency at that point. It was still chilled water or unitary rooftops. So we put that one on the back burner. Skip up a few years, about 5.5 years, 6 years ago, we realized we needed to do something. So we looked at a couple of options. Option one, do like what our competitors have done, go to a manufacturer, stick their sticker, you know, stick our sticker on their product. We thought about that.
That's exactly what I wanted to ask you.
Yeah.
Is who really builds these for you?
And where?
Yeah, all right, so we're gonna get to all of these things, and I'm gonna discuss it with you. So, the idea was that we had to look, we've got a big research and development team already that are used to split units. We know the split systems, we know the systems that are associated with it, indoor units, outdoor units, and let's face it, our competition has sort of evolved and changed the marketplace in such a way that it's not very difficult to sort of see what they're doing, see what works, and then play from that and work from there. Alright, so before I jump into our product as such, I first want to again tell you where the VRF fits into it. Then I'm going to just show you what that marketplace looks like, and then I'm going to tell you where it's manufactured, how it's manufactured, and everything associated with that. Just keep in mind, it's developed here in Texas, in Dallas. We've got a research and development team stateside that produces the product for us. Okay, so just bear that in mind. So we've got, in Lennox, we've got a commercial and a residential side. Residential furnaces, everybody knows that. There's nothing funny about that. Commercial side, we've got national accounts, Starbucks, Home Depot, all of these are our national accounts. Hotel chains, think of Hilton, Marriott, all of those are our national accounts. In fact, we've got the largest national account base of any manufacturer. In fact, some of them combined don't even reach our national account list. Because of that whole side of the business, we've sort of addressed solely to their purpose. All right. So national accounts, you'll get it from time to time, or you do a lease agreement or a big building, there's a couple of tenants in there. They will have in their leasing spec exclusive Lennox. They won't allow you to tender anything else. Some of them will be Lennox or an alternate, but some of them are exclusive. And that's really where these guys focus. National account, that's their job. Then North America commercial really speaks to everything else. So engineers, contractors, and everything associated with that. Developers, all of these guys fall under the North America commercial market space. That commercial splits and rooftops. Now VRF was sort of a difficult one to place, because do we want to put it under North America commercial and have it run under that team? Bearing in mind, we were a unitary company, used to unitary products. VRF is an applied product. If someone's not going to help you lay it out, you're going to run into issues, because every single system has its nuances. You need someone who's dealing with it day to day, day in, day out, that can give you those nuances and help you to work through them and select the right system for the job. So we decided to produce a whole new team, if you could call it that, VRF. It's its own management structure, it's everything associated with that under the big Lennox umbrella. That gives us a little bit more room to play with and work with, and it also allows us to play in the same way that national accounts and commercial play together. We play with all these teams together and make sure that we get the best outcomes. Okay? So, engineered for reliability. I was waiting for this slide. Where it's manufactured, why we didn't put a sticker on it. Let's get back to that. Okay, so when you carry another manufacturer's product, you've got to take everything associated with that's going to fall under your umbrella. So if we had stuck something on Team Blue's unit and made it a Lennox unit, we would have had to accept every sort of manufacturing defects, any liability claims, all of that would have to be absorbed by us. When we have no say over what's being developed, how it's being developed, what's being manufactured, or how it's being manufactured. We get a catalog, we order from that catalog, and that's what we get. All right? That's pretty much it. So the idea behind that was we want free reign of what we develop, so we can develop it from the North American market. We want to know how it's developed, and we want to know how it's manufactured. Now, we don't have a manufacturing facility in North America to produce our VRF equipment. You can imagine, you can't just have a whole line out of thin air, because a VRF manufacturing plant is something to behold. If one of you have ever seen it or gone up to the Europe areas or Asian markets and seen these manufacturing facilities, they're something to really behold. They're very intricate and associated with that. All right, so we had a look at all the testing that we wanted to do on here. So that's high RPM stress testing, insulated rotor tests, accelerated life tests. We wanted all this testing done, and we couldn't do that. So we partnered with a manufacturing partner. So a manufacturing partner. They have no say about what's being developed. They have no say about the research and development that happens stateside. All they do is they build. The company is called Medea. They are one of the largest manufacturing giants in the world. They are massive. They manufacture for the red team and the blue team and all these different competitors of ours, but they just manufacture. They don't sell, they build it according to our specifications. And Lennox took this so seriously, we established an office in China where this manufacturing facility is. We have a Lennox office with North Americans working in China, doing quality control for us on the ground while it's being produced. And not your front of house manufacturing line that all the other manufacturers will take you to on their tour, the back of house one that actually produces the equipment. Not the one with all the skilled workers, everyone looks pretty and they make it so, nicely. The one where the actual bulk of the equipment gets produced. So we've got guys walking those assembly lines every day making sure that the quality control is there. No other manufacturer in North America could say that because they've got no control over what they get. They just know their sticker's going to be on it. That's about it. Next thing to bear in mind is that they have their own manufacturing processes that they've got to comply with. So therefore they've got their own quality control systems in place already that all the other manufacturers are happy with. When it comes stateside, we rip it apart and we look at the first lines that comes out of each batch and make sure that they put the right breakers in there. We don't want a breaker that no one knows the name of it, a board that no one could get. We want to make sure that we've got the quality equipment that we've specified and that it is produced the way we want it produced. That's why our warranties are underwritten by Lennox. We don't have a third-party underwriter. It's Lennox carried warranties, and we've got 10-year parts, 10-year compressor as a standard on all VRF equipment. So that's got to tell you something. If we're willing to put our whole name behind this product, put all the necessary funding in to produce it, and we're carrying the warranties, and we're carrying everything associated with that. Remember at the beginning I said a keyword defects. All these issues. We own whatever is on this product that we sell. We make sure they work. We don't try and work around it. We don't try and, we bought it, it was an issue, we're trying to fix it now. It's not how it works. Lennox product, we took 3.5 years to produce this product before it was brought to market, and we now have a serious amount of projects already on the ground. Well over 100 active projects that have been running and are running without any issues. And every day a new one's being installed. Look at ACI's office, for example. They were so serious they're putting it in their office. So it gives you an idea of the commitment that we and our MRs are busy putting to the forefront on this. All right.
If you don't mind me interrupting, to further back that up, when we were researching VRF lines, one of the main reasons why we went with Lennox was they had their stuff together. I mean, when we talked to people, you saw a lot of people that were jumping the gun and running down the road with, inadequate support, inadequate product line, what have you. And Lennox really did a good job hiring quality people and having their product line well vetted before hitting the street. I mean, they're the best rollout I had seen to date. And that's why we chose Lennox. So go ahead. Sorry on all that.
No, thanks, Brian. Yeah, to speak to that, we don't sell it in markets where we don't have representation. So if we don't have a representative, you can't order our product here. There's no one to support you with it. There's no one to help you to make sure that it's actually designed properly. Yes, we can do it remotely on a onesie, twosie basis, but after that, we're going to have to establish a way of getting you someone here permanently, which we're doing that through our MR, ACI, and I am a few miles away.
So I've worked with a few different manufacturers. Several of them have a selection software.
Yeah.
They guide you through the sizing of the refrigerant piping, selection of the equipment. Generally, what I've done is have them do a quick review of it as well.
Yes.
Is it a similar arrangement with ACI then?
Yeah. Either we can run it for you, or you can just review your selections and vet it. Yeah.
Okay.
Yes. So we are releasing our software to our engineering teams. By that I mean you, the public. Will be released fairly soon, in the next month or two. The reason why it was held back, because we've been developing lines of equipment, obviously upgrading lines, new items. This morning, about a half hour before I walked in there, we had an update and a launch of our 5-ton mini VRF system. So the software launch, we've had the software, obviously we're on version 220 or something, that we've already worked through, and making it more aesthetically pleasing, easier for our clients to use. There's one thing for me to go and select something, but you need to understand it needs to be self-explanatory. Now that software will produce your AutoCAD piping diagrams. It'll produce your control diagram in AutoCAD for you. It will produce your full schedule of equipment with piping diagrams, again, schematics, pipe lengths, everything associated with that you put in, you get out on the back end. From your BMS control schematic, everything comes out of that. All right, that's what that software produces for you. We've taken that now a step further, which ACI doesn't even know about. We have a spec generator now. So if you have indoor units, an outdoor unit, MS box, branch box, all of these items, I can select them for you and we can produce a generic Lennox VRF specification for you written in engineering language that you can use, modify and adjust to suit your purposes. After this presentation I'll show you guys exactly what that looked like. It's no small feat, let me tell you, to take everything that's in an engineering handbook, put it in a way that you can format in Word and put it into your specifications to make it work. So that really is something. Being a consultant, I know putting specs together and making sure you don't oversee things is critical. And having a manufacturer give you sort of an initial draft of it that you can go and modify, that you know it ties back to the equipment you actually have on a project as opposed to generic VRF equipment, is really very valuable.
Is it like a dynamic spec? Like a
I'm going to show you.
Okay, sorry.
I'm going to show you. It's
No, I
not
got
per
questions,
size,
yeah.
it's like a medium static unit, right? Whether it's a 7,000 BTU or a 48,000 BTU unit, there are certain things that are innate to it. So we've got all of those laid out, and then you can go and deeper in and really, go from there. Okay. So the North American commercial market, to further establish ourselves, we needed to grow our market, obviously. That's where we're looking at in the VRF. We have unitary, we have a very, very large presence here. We had no applied presence at all, which is again why we went into VRF. We don't want to take away from our own market. We want to gain market share in other markets. All right. Last year I had this slide on, it was at 5%. It's now at 7%. And you'll notice this is JP Morgan. This is not something worth thumb sucking. It's not Lennox, it's everybody. That pie you're looking at is about $8 billion worth. So 7% of $8 billion, that's a serious chunk of money. Okay, so just that's something to think about, why everybody's bringing out VRF, because of that huge move and the volumes associated with it. Okay, we're following the world market trends at the end of the day. This is the only what is VRF slide that I've got on here. If people don't know what it is, single outdoor, multiple indoor, modulating gas valve, fully inverter driven compressors. That is innately what is VRF. Alright? I'm not going to go into detail with that. So if anyone has any questions as we go along, please ask me. Alright? Advantages of it. Now, it's really a comfort system. It's designed to be adjusted to suit your needs. Whether that's an open plan office or an office like this where you've got boardrooms, you've got open plan sections, you probably have cellular offices to a certain extent. It allows you to do all of that on a single outdoor system. On smaller buildings, you can do the whole building on that, up to 36 tons in our case. We can do it high-rise buildings, for example. Up in BC and Vancouver, where most of my business takes place, it's mostly high-rise towers that we're dealing with there. 40 stories, 42 stories, 36 stories. These are all switching over to VRF now.
Residential or commercial?
Residential, well, they're mixed use really. So the top floors will be residential, the bottom 8 is usually office space, and the real, the main level and the second level is CRU spaces, commercial retail spaces. So it really is dependent on what the developer wants to use, but we're seeing all of that switching over to VRF.
By switching over, you mean new buildings going in
Yeah.
or retrofit?
New buildings going in. To retrofit a VRF system, if you already have water source, you've got to get into those vertical risers, and getting in there is a little bit of a pain on an existing building. It can be done, but it's difficult. Now, what that allows the developer to do when you're selling a VRF job to a developer or a system as an option is very simple. A lot of developers, when I approach them with that question, why aren't you putting in VRF in your system? They're like, oh, but we're putting in gas in the system and I'm scared of gas and I want to put it in. I've got to go back and tell them, you've had gas in your buildings for the last 20 years, 30, 40 years. It was just a flammable gas, it was explosive. Now, all you're doing is you're putting in a refrigerated gas that it's an asphyxiant, but if you design it properly, it's not going to have any issues. It's not going to, blow your whole building up. So you've already had gas. Why is there a fear associated with that? Another thing that we've discovered, if you take this up with your insurer as a developer, they'll give you a reduced insurance premium. Because very simply, there's no secondary damage associated with VRF, as opposed to just you get in there, you fix it, you get out. So it's the damage associated with getting in there and fixing it, which you would have with a water system too. Except a water system damage ceilings, they damage computers, they damage walls, they damage paint. The whole 9 yards get damaged by a water source system. So at least up there, the insurance companies have gotten wise to this, and they're starting to offer them lower premiums by putting in a refrigerant-based air conditioning system.
While you're on that topic, what are the issues with dealing with the refrigerant requirements of the International Mechanical Code?
Are you talking about ASHRAE 15? The volume
I'm
of
talking about
refrigerant
Chapter
to
11 of the IMC about the pounds of refrigerant per 1,000 cubic feet of
per room volume.
room volume.
Yeah,
Well,
it's,
that
it's
trigger
my
is,
very next
machinery
slide.
and
ASHRAE
refrigeration.
15, yeah.
Okay.
Yeah, so it's very simple to get around that. I've seen, because we do the calculation for you, you know, those codes that when they were brought in, there's a bit of a back-end story why those codes were brought in South Africa. We don't even worry about them because we know no building is absolutely airtight. You're always going to have leakage under a door or some kind of a crevice. For example, makeup air systems, if you look at a range hood exhaust, very rarely do you supply enough fresh air to cope with the maximum airflow of that range hood exhaust. So you factor that it comes in from your corridor pressurization system. So how is that any different from you putting in, you know, having a catastrophic leak in that space and that, you know, air running out into your corridor pressurization system or out there? There's continuous air movement into that space and therefore out of that space. But that being said, under a catastrophic failure in ASHRAE 15, we need to make sure that we are within limits, and that is elevation-based. It's not to a lesser extent region-based, but it's elevation-based. Whether you're 3,000 feet above sea level or, you know, at sea level, it really is dependent on that, and that is what ties back to your concentration per square footage or cubic footage of air volume. And we do that calculation for you. In fact, I just did a calculation like that last week for a project up in Saskatchewan. I know it's halfway around the world, right? But we had to do that. Residential mid-rise, there's only 8 stories. And what we found was we can do up to about 600 square feet at about 9-foot ceilings. We could go up to a 20-ton indoor system while not exceeding that refrigerant volume, depending on the amount of refrigerant in the vertical risers, of course. So my software, if I've got all the pipe lengths, allows me to produce and simulate the exact amount of refrigerant that system's going to have in. You can add a factor of safety to that. We work on the room volume and we go from there. Now a lot of guys get hung up on the fact that, oh, but your washroom is only so big. You've connected ducting between the washroom and any internal spaces. There's innately there. And if you read the codes, it stipulates the moment you have ductwork in between and there's no fire dampers stopping that, it's linked and it's considered an open space.
Or transfer opening.
Exactly.
The ceiling, just
exactly. So it's very
extends
easy
the
to get
volume
around
of the
that.
space.
Yeah.
So it's helpful to hear you say that you address that issue, and when we have to respond to a building code review that questions that, you'll be there to help us with it.
Yeah, exactly.
Okay.
Exactly. In Canada, in fact, we've got a lot of the guys that are required to put that specifically for jobs for the Canadian government. They're required to put a table on there showing room volume, refrigerant volume as a staple name. It's got to be in there. Yeah. Every room, every volume of that particular system and the calculation associated with it. That's very simple to do, but you know it does get overseen, and that's why it's being called on now.
So do you use zoning or what to control the ratio between gas and room volume?
Well, the code stipulates a catastrophic failure. So the moment there is an indoor unit in that space, you need to consider the entire volume of refrigerant for that entire space. So that is the refrigerant that gets shipped with your outdoor unit, all the refrigerant in your piping, everything. It's if that whole system has to dump into that room, which again would never occur. Realistically would never occur. There are valves, etc. in place that will prevent that system from actually doing that. And even if that is the case, it would be gradual, which would mean a lot of that would dissipate. But that being said, if there is a catastrophic failure, according to code, you need to make sure that the entire volume is taken into account for that calculation. Right.
Thank you.
So we've got, our high-rise hotel over here. You're accounting for the volume of whatever the rooftop unit up there for the whole hotel in a single hotel room.
Yeah, but again, they only go up to 36 tons, right? So it's not like it's a 600-ton system you're talking about here. So it's small increments of these
Okay.
systems. So it's that system failure because the remains are not running through those spaces. So it's only that system's refrigerant piping that you're worried about that's in that space. Again, there are other ways of getting around it. Putting the indoor unit, for example, in the corridor means that you're effectively now linked the corridor and the indoor space all into one zone system. So there are ways of getting around that, especially in office development where you've got smaller offices than you would on a bigger platform.
Well, in that Saskatchewan project, you were limited to a 20-ton outdoor unit, is what
Yeah.
you're saying? Okay, not
Yeah.
a full 36.
Not a full
It
36.
could have been more
yeah.
cost effective to go that way. but
Because my
it's a
smallest was
refrigerator.
only 500 square feet. If it was 700 square feet, I could probably have gone up because most of the refrigerant's actually in the outdoor units, not in the pipework. Okay. The pipework doesn't incrementally increase that much when you're looking at the capacity and jumps as it goes up. Right? But that is something that we do. For this iteration in Saskatchewan, for example, it would obviously be more cost effective to do a larger system with fewer risers. But you've got to find that balance, and that's what we are here for. That's why Josh is here. That's